Okay. So my name is Kees Maals and I'm the project manager of IFSF. I want to say welcome to everybody who joined to this webinar number 3. This is the third webinar in the series of Unleashing the Power of IFSF Standards. In this webinar, Gonzalo will present it or discuss the Dispenser API simulator. The first webinar explained about where IFSF is about, and the second webinar was about the Dispenser API standards. They were explained in that second one. All the webinars are recorded or will be recorded and will be made available on YouTube later on. When you have questions during the webinar, please put these in the chat, and then during the Q&A session, Chris will read them so that we can answer them. And now I want to ask Gonzalo to start the webinar.
Hi, welcome to the third of a series of Connecting with IFSF webinars. As Kees mentioned, previous webinars covered available standards, its 3 generations, introduced the API-based standards, and the advantages of the Dispenser API. In this webinar, we will look into a real implementation of these APIs in one of the simulators, the Dispenser simulator. So here what we will cover first is all the significance of IFSF investment to launch a complete series of new simulators, what you will receive when purchasing these simulators, how to install and use the simulator, and last we will see how to control the dispenser, whether through the APIs or the controlling device. This presentation, the presentation that we will publish will include in a backup slide a video of the simulator that will complement this webinar. Why a new simulator generation? Launching a complete set of API-based simulators is a strong move of IFSF in promoting API-based connectivity. Simulators will help promote API-based devices by providing an executable and optional source code to jumpstart in future developments. Provide additional test scripts that IFSF is developing. This will allow developers to test real use cases. It also includes a controlling device to test most business cases. They are very simple to use, and they're in constant growth. For example, hydrogen features will be added in the short term, as well as error management. Most site devices are simulated, including a dispenser, a price pool, ATG, car wash, and a controlling device that manages them all. What you will receive. So let's focus on the dispenser simulator and what it includes. Here you will receive, first and foremost, the executable files. These will run on a Windows PC. We suggest a Core i5 or greater, but most Windows computers will suffice. Basically, what they need to run are CoreNet, SDK, client applications to be able to run it. These are not needed because they are included with the simulator, but if that runs, then it's sufficient. By design, the simulator can run on other platforms such as Linux and potentially Mac. We even tested them on a Linux Docker container successfully. But these implementations are not currently supported unless there is a specific member demand. Also, you will receive documentation that includes user manual, this webinar copy, a minimal Postman script that we will see later. This will help developers understand how to develop additional test scripts. There are also some additional usage videos and that show some use cases of the dispenser. Last but not least, you will receive a personalized license file that needs to be copied in the simulator root directory. This license includes the authorized simulators, as well as a license expiration if this corresponds. Each license is specifically signed for the member that is licensed to. Installing. So now we'll see how to install the simulator. So the first step is basically unzip the simulator into a directory and add the license file. So let's see how this works. We have a license file. I have unzipped it into this directory. In here, you will see all the all the files that are licensed that are included, including the license. This license is signed for our specific usage. Normally, this database is not included. That is an SQLite that includes all the dispenser operation. This one is automatically generated when it starts. So I'm going to delete it because this was for use. Deleting this database completely initializes the dispenser to scratch. So now I have done the same for the controlling device. I have it one level up, and I have it there that we will see later how it works. Now, using the simulator. Let's see how it runs. You can just double click on the simulator executable in the root path. This will open the simulator with all the default settings. But as I mentioned before, all the information is stored in the SQLite database. Resetting it to default is simply deleting that file, and it will create it on the next run, as we will see. When we run the simulator, you can run it using some specific additional parameters that allows you to set the port where the simulator is running. The simulator is actually an executable file that listens to HTML requests, and all the simulator interface is presented on an HTTP page at this port. Also, and depending on your needs, you can change it because some specific company requirements might be using this for some other purpose. Also, you can set up the number of fueling points to simulate. The default is 2, and we'll stick to this one. Also, the database I showed before that I deleted, we can set up the name. The default is the one that is created, but if we use different databases, we can have different databases with different test scenarios. For example, we could have with more fueling positions, with already in a previous save state to launch a script, or with previous transactions that a test script might want to make sure that they are to start a new test. Also, you can set up the security schema. The default security schema is IFSF, that all messages need an API key to connect. There are other schemas, for example, for Connexus, we can use OAuth authentication, and we need several additional information for OAuth. We will not be covering this. We will work everything with API key. And you can change the API key. This API key is just the key that is used to connect for any API to connect to the dispenser. This is not related to the license. This is related to the device security key. We are using for the simulator a 1, 2, 3, 4, 5, 6. It could be changed, but also definitely if you make an actual device, you should use a different key that you will have to agree with controlling devices in the market. For example, a POS, if it needs to connect to a dispenser, you will set a specific one that you will give to the POS provider so they can connect. So this is important. I wanted to differentiate the license versus the API key. To stop the simulator, you can just stop it by pressing Ctrl+C and closing the screen. So let's run the simulator in default mode for now. So let me switch to the dispenser, okay? I already deleted the database and I run it. When I run it, it starts. This is the creation of the database, and now the database is created. The simulator is running and it's listening on its default port that is 5020, as I mentioned before. So if we open a web page. Let me just open a Chrome for a moment. Here, if I select localhost 5020, I'm able to see the dispenser simulator. So let me put it in full screen. Here we have it running, and we can see the different sections of the simulator. The sections will include all the calculator information, that would be all the settings of the dispenser as a whole. The FP tabs are each fueling position. So here we have fueling position 1 and fueling position 2. All this information in all these sections will refer to each fueling position. So let's go back to the first one. All the demo we will do will include the fueling position 1. Also, you have all the fueling position data that includes configuration data and control data. So for example, if I open the control data, I can see, for example, which is if it has a preset, if it has a remote amount, the price mode that it's selling, and so on. All this is the control data. In the configuration, you can see, for example, default fueling mode, if it wasn't overridden in an authorization, the idea of the fueling point, the buffer sizes, and the name of this record. And if it's in zero transaction mode, that this means that if I do a zero sale, it will generate a transaction or not generate it. All these different modes are supported. This section represents the dispenser face with buttons to simulate lifting a nozzle and opening or closing valves. This is just as any dispenser you would see in the market. And you have on top here all the different displays of the dispenser. Here we have a section with the states. These states, let's say if you authorize, for example, you will see that it's authorized. If I lift a nozzle, it will now be in calling state. If I put it down, I will go back to ready state. Here I have all the data of each nozzle, all the information related to that. I will be able to see, for example, if the nozzle is locked, its product, and so on. Transaction data, we will see later that whenever we finish a transaction, the transactions will appear here, and we will be able to see if it's payable, if it's logged or cleared, and all the details. Last, we have all the different errors, but this simulator is not generating errors right now. The data is available for APIs for integrity of the APIs, but the simulator is not actually simulating the existence of errors. Below, we can see also who is connected. Okay, I have in background the controlling device open, so that's why here it says that the controlling device is connected. And all this user interface is the same UI that also needs to connect as any controlling device that is actually controlling the dispenser. So these two are the connected devices. Here we can see all the server sent event messages that include all the information. By clicking in here, we can open a new tab with all the different events, and here all the events will be logged. Here we are seeing the different ready events, and we can hide them because this is normally a heartbeat, and heartbeats make a log dirty to understand. So what we do is we hide it, and then whenever an authorization or an actual event that is not just the heartbeat will be appearing here. Last, and also, sorry, there are two more sections here that include the database information for the dispenser that is accessing all these different information sections. We can access through this database. For example, I can select, for example, all the general data, or for example, for a fueling position, the configuration data I showed before. I can show it for the dispenser, for the fueling position 1. I can see the same information that I showed before in the dispenser screen. But this is accessing it through each data set and corresponding record, simulating the long database. So one of the features of the dispenser APIs as were designed were that they were able to expose the complete long database, and here we see how it's exposed. And the last section we will see here is this Swagger UI tab. This allows you to see all the published APIs, and it doesn't only allow you to show them. This allows you to run APIs from here. We will show later how this will run. Right now, I'm going to minimize this to simplify later my search for each API. But all the different APIs are published in here. The simulator also includes the company that is licensed to. This comes from the license file and the version. We can also hide several of these screens to make this more readable. Also, for example, the states, if I want to make something very small, I can put the states in a very simplified form that is so small I cannot include the texts, but it will still be showing you, you see, it went into calling, and if I put the nozzle down, it's back to ready. So this is only graphical. This is the complete detail if you're not familiar with this. So let's go back to the presentation. These are the main features that were covered in the demo I just made. So now let's see how to connect to the dispenser APIs. We have, let's say, there are several ways to access these APIs. Basically, any tool to connect to an API in the market can be used. And but we are going to present here, we will focus on three main options: using the self-documentation that I just showed before, using a Postman script, or using the controlling device simulator I already opened. So using the self-documentation, I will first display it here, and then we'll see an actual demo. As I showed before, with this icon, we can open all the Swagger documentation files. And this is all the self-documentation of the APIs. You will see the complete list of APIs, and you can run the APIs here. So to be able to run it, you first need to press into the Authorize section, and here it will request you the API key to connect. Here, as I mentioned before, the default API key that we haven't changed it now is 123456, and we select Authorize. That authorization is cached for all the future connections that the API does. Then to execute, we can select, for example, the fueling position state. We identify the fueling position, and then we execute. This we'll see it later. Once we run the run now or execute, we will see the API execution. Here you will see all the results, and you can see an equivalent curl that also could be used to run tests in a batch mode, similar to Postman, and also the actual response from the dispenser. As you can see in this, this is the curl it's executing. Here you can see that it's automatically inserting the API key 123456 we included before to run it. So let's see this in actual practice. Here we can see fueling point information. I can select the state. Remember, I already included, no, I didn't include here, 1, 2, 3, 4, 5, 6. I have the API key defined. Now I'm logged, let's say this is how this considers. And then to get the state, I can try it. When I try it, as I mentioned before, I need to include the fueling point ID and execute. This execution will generate the script with the API key, and we'll get the result. We saw here in the simulator, let me go back to the phase, the simulator is ready, okay? So when we see the result, we will see that the state is ready. There's nobody's locking it. and all the different state, the nozzles are all down. So this is, we can see here the complete status. Let me show you another quick example. If I log out here, so I remove the API key, and I try to execute this action again. Sorry, no, it doesn't. Now it's already stored the API key, so I will not be able to. I wanted to test without the API key and show you the failure, but it seems it's already sending it. No, here it is. Yeah, you see the curl is being updated, and I'm receiving an authorization error. Why? Because I didn't send any API key. So this is, we are actually checking the API keys, and now if I authorize again, and I authorize it, I close here, and I execute it again, now I get again the results. So you can see the APIs are actually operational and running all the tests. So let's go back to the presentation. Another way is using Postman to control the dispensers. Postman is a tool that allows you to run scripts and store scripts already configured, and you can automatically run a sequence of tests or run an individual test. In this case, with the dispenser, we will receive a very small set that will have 9 requests, and that they are very basic. For example, simulating 2 controlling devices that are connecting. Then we will check the state of the dispenser. We will see that it is not reserved. Then we reserve it with one of the controlling devices. We will make sure that it's actually reserved. Then we'll check the state again, and we will see that the dispenser is idle but reserved by the first controlling device. Then we'll do another test that is trying to reserve it with another controlling device. And obviously, as it was locked by controlling device 1, then it will return an error. Then we'll clear the reservation and check the state again. All these 9 requests internally is doing several tests to make sure these are checkpoints that will show you the actual results. This specific test includes 38 tests, or that in Postman are called assertions. So let's see this in the Postman. I have Postman already open, and here we see, for example, the connection. I will send within the header my API key that I have it. Oh, I have it in an environment. This is my environment, okay? So if I now select it here, it's not resolved. Sorry for a second. Oh, this one is the environment, sorry. Yeah, now we see that we have it configured. Then in the body, I'm sending the controlling device 1 data, the current date, and I will, when I receive the result, I can test that, for example, the environment, the API, sorry, this is a pre-request where I set up some environment information, and then when I see the results, I check that I get a 200 result, that it's a success, that the error code is RCD OK, and the message that this is something that shouldn't be checked, but that is operation completed successfully. Same we are doing for the other. So if we run this simple test, for example, here I will see that I have the 4 tests were successful and everything worked. Also, this same test, what I can do is run it all together. Let me just close lots of windows I have here, because I have, sorry, I'm using this for another presentation, and I have too many tabs open. Here we have it. So let's see if I have the dispenser example. I can run the complete test as a sequence. So we put it here, and it allows me to run all these 9 tests. So I run it, and here we see that I was able, let's say I was able to connect. All these are the results. Then I will see here, for example, that the locking application sender, when I test, once I connect it and I test the status, the locking application is null. After I request a reservation, it will now be reserved because it was successful. So the new status will be that the controlling device 1 has reserved the locking application sender. If the controlling device 2 tries to do a request, I'm going to receive the error device locked. And this was successful because this is what happened. And then I delete the reservation and so on. So let me, for example, now go back to, now everything is free again. So if I run a status again, I can run this one by itself, and I will get again that there's no logging application sender, that is ready, and everything is successful. So this shows you how to run them. One of the advantages of creating these test scripts is that you can run them with an automated tool. This tool is called Newman, and you can run it just as a batch and run a complete set of tests automatically. Let me show you an example. This is a report that is also from a set of tests that we use to run using this Newman tool. It's running all the same type of tests that were created for Postman, but this one is far longer. It includes 150 requests, and these checkpoints or assertions are more than 1,000 assertions. I will not be digging into this one very much, but I wanted to show that this one is very useful. It's very practical because it will allows you to automate all your testing. Also, you can see here each and of every test and all the results. So it's very detailed information. So this is another of the methods. So we already presented how to use Postman. We presented how to use the dispenser interface. And now let's see how to use the controlling device. So this is the third way to control it. So I'm back on the presentation, and let's talk a little about the controlling device. The controlling device is also a simulator that allows you to, through a single interface, manage all the different, all the other simulators, all the devices. It can run, for example, the price poll simulator, the car wash simulator, the ATG simulator. It is installed pretty much the same as the dispenser, uses the same license. Let's say when we send you the license file, that will include not only the expiration, it also includes which are the devices that are licensed for you to use. So let's see it in action. So let me just go now to the Explorer. Okay, I have, where is, here it is. So the dispenser simulator is running on port 5010. So if I refresh, I will see. To make it easier to see, I'm going to put this in two screens, one for this and the other. I'm going to put the controlling device. So we'll keep it in two screens. As there are too many screens here, I'm going to hide the ones that are not of interest. I'll hide the calculator. I'm going to hide the fueling point data. I'm going to hide the logical nozzle data that's not of interest, and all the errors. Also, the messages, I'm going to hide them on the controlling device also. It's not needed. So here we see the controlling device. And for example, from here, I can see that the fueling point 1, okay, I select it, I see it's ready. And here, for example, I can reserve the dispenser. When I run this, I can see in the controlling device that is reserved by the SIM-CD. And I'm seeing a green button stating that it was actually reserved. I can later authorize it. Let's suppose I authorize it for $5 or whatever currency we use, and we authorize the dispenser. So when we authorize it, now we can see here that the dispenser is authorized, that we can see it also in the controlling device, and we are ready to use it. Now we can lift the nozzle, we can open the valve, and it starts dispensing. And we can see real time in here and how it's working. So if we put it down, we finish the transaction, and we have here 1.32. Here we can see that there is this transaction is available. As I mentioned before, in the transaction data, we can see all the transaction buffer. This transaction is logged, and here we can see that also the details, for example, the amount, price, and unit. Also, you can see in the simulator, the blue button, this shows, as you can see here in the quick help, that they are pending sales. So all the information needed to control is completely simulated by the controlling device. Then let's suppose we are simulating a payment where the user tries to pay, collects the transaction. Normally the POS will log first the transaction. Oops, transaction log. Oh, this was reserved, so it's already logged by this one because it was reserved. It was reserved by me. I can also clear it if I want. You can see now it's cleared. I can lock it back again. ¿Qué pasó? Che, no me. Oops. Let me refresh. Oh, sorry. I cleared the transaction, so it doesn't appear anymore because the transaction is cleared. I paid for it. I was trying to unlock it. That was my bad. So, well, it's actually doing what I'm requesting. So that's the good part to see. So let me now, we can also see all this from the different APIs. Let me show you. If I open the Swagger, okay, again, that I have it here. So let me show you, for example, I will repeat all this sell transaction, but from here. What I'm going to do is an authorization. So I already have my credentials, so I can come to fueling point 1. I need to include an application sender. We already saw that, for example, SIM UI was a connected application, so I'm using this one. And I'm not going to send anybody. In the body of an authorized, you can include, for example, the maximum volume, the maximum amount, and release products, and so on. Or even that we can need a consent. This is used for specific when you need to do double authorization due to certain laws in USA. So I will remove all this and use all the default. That would be an unlimited authorization for all hoses. And if I execute this, I will see that I have success, and I will see that the dispenser is authorized. Again, if I come here to see the controlling device, I'm seeing also that it is authorized. So everything is in sync. This is working as a different controlling device, and everything is working smoothly. Now I can lift the nozzle, okay? Now it started. So back to the controlling device, I see that the dispenser is started. I can open the valve. It will be fueling. It's running the fueling. And when I bring this one down, it's back on ready. So being ready now, here we can see the originally clear application and the payable application, same as we can see here. And if I go to the API, for example, let me close this, I can see the transactions, and I will be able to get all available fuel transactions. For fueling point 1, and again, I will see the same I see here. I see the first transaction is payable, and the transaction number 1 is cleared, and the transaction 2 is payable. Let me try to make it larger, but so you can see it better. So it's consistent the API with the simulator and here. So again, I can log it from the dispense, for example, from the UI, I can run directly a clear transaction. That is basically to delete the transaction, as this is transaction number 2. I just come to the transaction, try it, select that is, fueling position 1. I said sim UI I'm using as controlling device, and the transaction ID is 2. Once I run this, I have the transaction cleared. In the controlling device, if I refresh the information, I have the transaction cleared also. So you can see, you are able to see here by doing APIs, by using the controlling device, and by using the postman, all the different ways to interact with this controlling device. So this covers all the dispenser simulator presentation. Any questions?
I have a question on the license file. So you really need a license file before you can really run the simulators, and the API key, that's just a separate thing. How does that work, Gonzalo?
Yes, the license file is basically a file that allows you to run the simulators. It has nothing to do with the API key. The API key is how the clients, how any controlling device that's connecting to the simulator is the key to connect to the simulator. The license file is completely independent and is used to run the simulator. This is the license to be able to use the simulator, and the key is part of the standard to be able for a controlling device to connect to the device.
Thank you. Is there anybody who wants to ask a question directly? No, if somebody is interested on getting to know more about this simulator, or to use it in your organization, then please contact me, projects manager at ivsf.org, and then we will see what we can do. Thank you all for attending this webinar, and have a nice day.
Thank you very much.